Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 5.3, Problem 4. This is Section 5.3, Problem 4. It says Sally has $36,000 of student loans. She has 10 years to pay them back at 9%. What are her monthly payments? How much interest will she pay? So this is a loan amortization question. Again, they're fairly easy to spot. The formula is P, the monthly payment, equals A, the amount borrowed, over some very large brackets. And in the numerator of those brackets, you have 1 minus 1 over 1 plus r over m in parentheses raised to an exponent of m times t. In the denominator of the brackets, you have r over m. So to fill that out, we will have P equals A, the amount borrowed for this problem is $36,000. And I'll fill in the brackets underneath that. In the numerator of the brackets, 1 minus 1 over, in parentheses, 1 plus r over m. So r, the rate as a decimal, the rate is 9%. So as a decimal, that 9% would be written 0.09. Over m is the number of payments made per year. This problem is fairly typical. They want monthly payments, so m is 12 because there are 12 months in a year. I will close the parentheses, and it has an exponent of m times t. Again, m is number of payments per year, which is 12, and t, the number of years for the loan, is 10 for this one. So t is 10. And in the denominator of the brackets, you have r over m, so 0.09 for the r and 12 for the m. And now we'll start the computation. As usual, when we have parentheses, you need to deal with those first. So I will have P equals 36,000 over my brackets. And the brackets will have in the numerator 1 minus 1 over. Now 1 plus r over m. The r over m, 0.09 over 12, again, I happen to remember is 0.0075. If you don't, simply use your calculator. 0.09 divided by 12 equals, and it'll say 0.0075. Now there's a 1 plus in front of that, so 1 plus 0.0075 is 1.0075. And that 1.0075 is in parentheses, and it's raised to a power of m times t, which is 12 times 10. So the exponent is 120 from the 12 times 10. And the denominator of my brackets, I have 0.09 over 12 again, which I can simplify to 0.0075. So now I have a large exponent of 120th power that needs to be dealt with when we move to the next step of the process. So what will happen is I will have P equals 36,000 over the big brackets still. And my big brackets will have 1 minus 1 over. And the 1 over, the value will be 2.4513577078. And then in the denominator of the brackets, I still have 0.0075. Now what I want to do is I have 1 over 2.4513577078. I want to do that division. And again, I like to do that by just keeping the 2.45 something on the screen and pressing the 1 over x button. So that's going to give me P equals 36,000 over the brackets. In the numerator of the brackets, I'll have 1 minus, and it's 1 minus 0.4079370305. And in the denominator of the brackets, 0.0075. So I can finish the numerator of the brackets by doing 1 minus 0.407937305. And that'll give me P equals 36,000 over the brackets, and in the numerator of the brackets, I'll have 0.5920626695, and in the denominator of the brackets, 0.0075. So I can take the brackets down to one value by dividing 0.5920626695 divided by 0.0075. And after I complete that, what I'll get is P equals 36,000 over 78.94169267. So to take it down to the monthly payment, I'll divide 36,000 divided by 78.94169267. Again, I'll use the memory on the calculator to stop me from having to type that all in again. So the calculator says P equals 456.0327855. Now I don't want that many places after the decimal my final answer, so I want 2 places after the decimal. So after the decimal I have 0.032 something. It's not big enough to make it 0.04 or 4 cents. So the monthly payment will be $456.03. It's paid every month to pay down the student loans over a 10-year period. Now the second part of the question is, how much interest will Sally pay over the life of this loan? Well, she's going to pay $456.03 every month for 10 years. So that's 120 payments, right? 12 months per year for 10 years. So she's going to make 120 payments of $456.03 each. So I'll multiply 120, the number of payments, times 456.03, the value of each payment, and that will give me a total paid back of $54,723.60. Again, the calculator says 0.6, but I want to think of it as money, so I'll make it 0.60 for 60 cents. So the lender gets paid back almost $55,000, but of that, $36,000 went to the school, wherever it was. So we can do the result of $54,723.60 and subtract off the $36,000 that the lender does not get to keep. The school would get that. So let me subtract that off. So the interest paid on that student loan is $18,723.60. That's a lot of interest. It's a little more than half the value of the loan. And $36,000 isn't that big of a loan as student loans go. It's a lot of interest.